technique is useless on me!
Man, how cool would it be to live in the Avatar universe?
Yeah, Karis could be an earthbender, Jensen could be an airbender, and me, I've always wanted to be a waterbender. I could do things like this, and this.
But in real life, these types of waterbending are not possible.
It's okay. There are other real-life types of waterbending that are just as cool. Introducing the Vortex Ring.
A vortex ring, also known as a toroidal vortex, is formed when a fluid is discharged from a nozzle or orifice impulsively into an idle fluid. The shear imposed on contact between the two fluids slows down the outer layer of the discharged fluid, detaching the flow and causing it to curl and roll up into a vortex sheet. The vortex sheet then moves freely downstream due to its self-imposed kinematics. This is similar to the vena contracta effect as observed in our orifice plate meter experiment.
However, the lifespan of the ring is finite. The ring will eventually break up into smaller bubbles due to two factors. First, the ring core will expand as it moves, which will cause the surface tension to be less effective in stabilizing the ring. Second, although a faster rotation of the ring stabilizes it, the viscosity and the drag force of the surrounding fluid will eventually outweigh the stabilizing effect. We found the vortex ring so cool, we tried it out right here in NUS.
Wanna know how this works? Let's find out.
As the die escapes the cup, the die that edges encounters shear force with the cup's opening. This results in an outer surface slowing down with respect to the center. This then produces a rotation in the shape of a torus, and thus a vortex ring is formed. As the ring moves forward, its velocity decreases as a result of frictional force encountered against the water. As radius is inversely proportional to velocity, as explained through angular momentum, this causes the radius of the vortex ring to increase, thus resulting in the vortex ring expanding radially in this inviscid fluid, in this case, water.
The friction between the vortex ring and water that causes the velocity of the vortex ring to decrease is not equal at all parts of the ring. The sides experience shear force, and the front of the ring that meets the water experiences the most friction. The difference in pressure and friction will deform the drop into a swirling donut shape. Eventually, the vortex ring fragments into smaller clusters where the ring becomes thinner than a few millimeters. This is due to plateau-Rayleigh instability. When the vortex ring reaches a certain thickness, surface tension effects distort the ring's surface, pulling it apart into separate clusters.
Here's a diver making his own vortex ring underwater by releasing a small burst of air and causing water to spin in a donut shape to form the vortex ring. And the ring is actually strong enough to knock over rocks. Isn't that insane?
This is cool, but how can we make our vortex ring so powerful? We suspect that Reynolds number is one of the factors affecting the progress of water rings, as it is the fundamental concept to a lot of fluid mechanic problems. To verify this, in our own experiment, we increased the velocity of the surrounding water by shaking the table where the container is placed, while keeping the rest of the variables constant. The result shows that the turbulence in the water caused the water ring to break faster than our controlled experiment. Our finding also aligns with results from credible research. For example, this picture taken from an A-star research shows that higher Reynolds number of surrounding fluid results in more unstable vortex rings. Recall this figure that was shown earlier in the video. As Reynolds number of the water increases, the vorticity of the surrounding water increases as well. The different vortexes at different contact points with the liquid jet will create different velocities, making the vortex ring harder to form as it needs relatively constant velocities in the water layer.
Surface tension also contributes to the stabilizing effect on the ring, because the water molecules would experience a larger force between them, pulling them closer together, and hence the lifespan of the vortex ring would be prolonged. This research finding has the same result as our experiment. In our experiment, we added salt to the water to increase the surface tension of the water. The vortex rings formed in the salt water visibly stay for a longer time before it breaks apart.
We also noted that adding salt decreases the Reynolds number of the fluid, which also contributes to the stabilizing effect as discussed earlier. As our literature suggests, Reynolds number and bond number, which is inversely related to surface tension, are the two most significant figures affecting the evolution of vortex rings. Hence, we propose the stable development of the vortex rings in our experiment to be a combined stabilizing effect on both decreasing the Reynolds number and increasing the surface tension.
So hey, maybe water bending isn't just fiction. You can also kind of do it in real life without bending reality. There's still so much more we can learn about vortex rings, and what we covered here is just a drop in the ocean.
And now that we've mastered water bending, let's do air bending next. Anyways, thanks for watching this video, and see you all.